welcome to our presentation on investigating the gender wage gap across industries. I am Sai Teja, performing the role of an empirical analyst, and my teammate is Leela Krishna, who is the critic. In this project, we aim to analyze the wage disparity between men and women across various sectors and how factors like experience, education, and occupation contribute to these wage differences. We employed a range of empirical methods to explore this issue, and through the process, we have made several improvements to our methodology based on feedback. The research question we are addressing in this is how do industries experience, education, and occupation affect the gender wage gap? To answer this, we generated a synthetic data set and applied statistical analysis and regression model to uncover key patterns. Coming to the data set, we chose to use synthetic data set for reproducibility and to have a more controlled environment. In this data set, we have 5,000 samples uh, with the following features: gender, male or female, years of experience, education level, industry, etc. The wages were modeled with a formula that includes experience, education, gender, with additional random effects for industry and occupation. We have employed several statistical methods to analyze this data set. First, we conducted t-test to check for gender-based wage disparities. The result shown in this first iteration show that the men were paid higher than women, which is consistent with the expected wage gap. We also used ANOVA to assess the impact of categorical variables such as industry and occupation on wages. The ANOVA results confirm that the industry and occupation have significant impact on wages, especially in high-paying sectors like finance and IT. We can see the results in the first iteration. We have improved our R squared score to about 0.47, whereas the baseline code had only about 0.27. Further improving on the first iteration, we have improved significantly, getting a score of 0.76, and in the final iteration, we have achieved the score of 0.99. Coming to regression analysis, initially we used linear regression to predict wages based on our features. In the first iteration, we encountered some issues with multicollinearity, which is common when predictor variables are highly correlated. To address this, we switched to ridge regression, which handled multicollinearity better and improved our model performance. We then conducted residual analysis, ensuring that the model wasn't biased and that the residuals were normally distributed. These residual plots show that our model was well calibrated and generalized well. Finally, based on feedback from our methodology critic, we made several adjustments to the interaction terms and model refinements to ensure a more robust analysis.
I think I am audible and my screen is visible there.
Mm-hmm.
Um, as he already introduced myself as a critique in this project, I have critiqued some methods which we used and we discussed some of the areas of the improvement and we implemented them. And coming to the baseline code, initially the methodology which we used in the baseline code was very valid and it had some of weaknesses to it. The relationship between experience and wages was overly simplistic. In this, we are not very satisfied, so we just went on with the first iteration where the experience effect was modeled linearly, and it doesn't reflect the diminishing returns typically seen in the real world wage growth. And this was a key weakness. To correct this, the logarithmic transformation of the experience variable in the second iteration addressed this issue, and making this the wage relationship with the experience, this made it more realistic. However, there was some overfitting due to which specific biases such as the interaction effect between the gender and occupation, which are left too narrow. So in the final iteration, we went on to make some other changes. Uh, we generalized these biases in the final iteration and removed the unnecessary noise, allowing the model to focus more on more meaningful interactions between the education, industry, and occupation. This provided a clearer understanding of how these factors influence the wage disparity. We also addressed the multicollinearity by switching the ridge regression in the final iteration. This allowed the model to perform better without being influenced by highly correlated predictions. Another important adjustment was in the visualization of the results. Initially, the visualizations were too basic. In later iterations, we added the residual analysis, heat maps, and scatter plots, and that gave a clearer understanding of how the data was distributed. And these are our final visualizations. Ethically, we needed to consider the gender bias and ensure the model didn't perpetuate stereotypes. In the final model, we removed overly specific biases and ensured that the results were representative of real world wage gaps. And coming to the limitations and some other things, uh, while our analysis showed significant gender wage gaps, there are ethical considerations to keep in mind. The model is based on a synthetic dataset, which means the results are only of a simulation of a real world data. There is always a risk that the model may underestimate or overestimate the wage disparities in actual industries. Additionally, while the model showed us the impact of of the gender, we could refine it by including the other socioeconomic factors to make our analysis more comprehensive. Concluding our argument, our analyst will continue here with his points, and then I will be concluding it.
Yeah, so concluding this presentation, in our analysis, we did confirm the existence of a gender wage gap across various industries. The final model is more robust, and the insights we gain provide a foundation for addressing gender based pay disparities. The adjustments made during the iterations improved the accuracies and interpretability of the results.
Concluding my own points, we have addressed critical weaknesses in the original methodology, such as overfitting, multicollinearity, and gender biases. And we believe the results are now more representative of the real world challenges in addressing the gender wage gap. And finally, we take this step to conclude our presentation here. Thank you.